Okay, here we go. So click and close. I need you with me here.
Manny's like,
Okay, hopefully you'll get a chance to get back into this today. If not, you're going to get a little more time later in the week, and you'll have some time. So tomorrow, we're good to go tomorrow with a retake day.
Yes.
Okay,
Yeah.
retake / work day.
Yeah.
Okay, that's good. And then Friday we'll jump back into this stuff. Okay. So what about number 4? Number 4, we started off with, we don't have, that's the original equation, right? We're trying to put it into standard form. Remind me real quick, what are our rules for standard form?
A's gotta be positive.
A's gotta be positive. What about A, B, and C? What do they have to be? No. A, B, and C, A, B, and C, can they be fractions?
No,
Can they be decimals?
no,
What do they have to be?
greatest common factor.
Integers, right? They have to be integers. Can't be fractions, can't be decimals. Let me go back, rather than just saying all these things, let's go back to the page where I wrote them down. That's back here, right? So the rules are, for standard form, A, B, and C have to be integers. AX plus BY equals C is standard form. A has to be positive, and then the third one is, this is kind of the little trickier one. The third one is, the greatest common factor of A, B, and C is 1. So if I can divide something into all, A, B, and C at the same time, I've got to do that, right, to make the number small. Okay, so then, with number 4, what's the obvious problem with that one?
Fractions.
They're fractions. I got to get rid of the fractions. And we've done a lot of this, right? How do we clear fractions? We multiply through, we distribute through the whole equation, the least common denominator of all the denominators. In other words, that's a least common multiple, meaning that's the smallest number that 5 and 4 and 2 all divide into, which would be 20, wouldn't it? Everybody agree? Okay. So when I distribute the 20 through, what do we get? Well, 20 over 5 is going to give me 4, which I multiply by 3 and get 12x. 20 over 4 is 5, so we cancel that, and then we have the 5 left over to multiply by the 1y. 20 over 2 is 10, which we have left over to multiply by the negative 1. I get negative 10, and I'm done. That's it. Okay? No big deal. Okay, so for today, pull out your notes. We're gonna continue with the notes a little bit. If you want to be requested, I've got a request sheet up here too. Okay, so let's take a look at an example. I'm just going to take a random line. And I want see if you can, don't say it out loud, but see if you can tell me what the equation of this line is. What form am I going to write that in?
Slope-intercept.
Slope-intercept, right? So we want to fit the form y equals mx plus b, right? Okay, can anybody tell me, somebody raise your hand and tell me one thing, what number we could plug in there? Ronnie, what's one thing we could plug in?
Positive 3.
Positive 3 for
B, right?
for b.
Or Y.
No,
No?
no, hang on.
Much.
I've got to plug in, so what are the numbers I've got to plug in are m and b, right? Are you thinking about m?
No, I was thinking it's B, but.
Okay, so what, b is the y-intercept. What does it mean to be the
Oh,
y-intercept?
so negative.
Negative 1, there you go. Okay, so the y-intercept is negative 1, isn't it? Right, so we can see, in fact, let's do this, I'll make that point green. So that corresponds to b, so we know that that's going to be a 3. What about the slope? The slope can, 4, how'd you get that? You're right. Okay, good, so it's gonna rise, to get from this point to this point, we rise by 4, and we run by 1, so that means the slope must be 4 over 1, right? Okay, so we end up with a slope of 4, very good. Now, think about this equation here. What is this equation doing for us? This equation is relating the x's to the y's, right? Is the point, you tell me, is the point x equals 4, y equal 1 on that graph? The graph of the line? It's not, is it? Look at the coordinates of that point right there. Positive 4, positive 1, right? It's not on the line. Could you prove that to me by using the equation? What could you do? Okay, that doesn't work, does it? When I say it doesn't work, do you understand what I mean? If I plug in x equals 4, am I getting a y value of 1 back? I'm not, am I? Right, if I look at this line here, and I plug in a value of x equals 1, what's the value of y that I calculate from my equation? We could find out. I'm just plugging in 1 for x, right? So what's that give me? If I plug 1 in for x, I get 4 times 1 is 4, plus 3 is 7. Okay, so if I go over 4, I should have to go up 7 to be on the line, right? Okay, we're going to come back to this stuff soon, but what I want you to see now is that the x's and the y's are connected by that equation, right? If I pick a certain x value, the y value is going to be given to me by this equation if I plug that value in. I could do the same thing for y's too, by the way. What if we started with a y value? What if I said, let's pick the y value, what if I pick the y value? Well, what did I get? How did I get my b to be 3? That's not right. Looking at that, isn't match the graph. What did Rodney? You didn't tell me it was 3. What did you tell me it was? Negative 1. There we go. Good. So I got to change this.
I thought it was triple.
Yeah, no, you weren't. I guess I was. Right. So what's the? So what value do we get then for? If I plug in 1, if I plug in 1, I'm going to get.
3. No.
I get 4 times 1 minus 1. What is that?
3.
3. There we go.
I said 5.
And that makes sense, doesn't it? Because what are the coordinates of this point right there? They're 1, 3. That was my mistake. Everybody see that? And we can see that is a point on the line, right? So I'm going to give you another one now. What if I, this time, instead of starting with a 1, what was the x value? Let's start with the y value. Let's start with like a y value of 7. If I wanted to calculate the x value, how could I use my equation of the line to do that? What do you think? Hey, Alani, what would I do? Yeah, sure. So let's say, now, the last example we did, we started with x equals 1, and we calculated the y value by just, substituting the 1 for the x. This time I'm saying, okay, this time we're gonna say that the y value has to be 7. What's the x value that goes with that? How could I use that equation? What would I do with that y value to find x, do you think? That's it. Plug it in, right? So we're going to use the equation. What does the equation do? It connects the x's to the y's, right? So if I know a y value, I plug that in and I find the x value with the equation. Or vice versa. It doesn't matter. It works both ways, doesn't it? So if we plug that 7 in, where'd that go?
You moved it.
I guess these things sometimes, I don't know. What does it do? If I plug the 7 in for y, I'm going to get a 7 there equals 4x minus 1. What are the steps to solve for x?
Add 1.
Let's see. Yeah, add 1. There we go. That's good. It worked the way I wanted it to. So if I add 1 to both sides, I'm gonna get what?
8 is 4x.
8 equals 4x, so what's x?
Oh, 2.
If I divide by 4, I get 2, don't I? Good. So we get x equals 2, and so there's another point, right? If I feed it a y value, the equation gives me an x value, okay? But they're changing, aren't they? When I plugged in 1, I got a y value of 3. When I plug in 7 for y, I got an x value of 2. Both the x's and the y's are changing based on that equation. And that's the job of the equation, is to relate the x's and the y's, the inputs and the outputs, right? So what if we talk about horizontal and vertical lines? They're much simpler. Okay, now I want to use what we just talked about to understand how we deal with horizontal and vertical lines. Because I guarantee everybody in here has just memorized some stuff about horizontal and vertical lines. And like state capitals, you're going to forget that. So we got to attach it to a concept so you don't forget it. There's my vertical line, and here's my horizontal line. Let's find names for those. What about the vertical line? What do you think the name of that is? I write that equation.
What do you mean?
I mean, I want to know, just like this line over here had the equation y equals 4x minus 1, I want to know what's the equation of that blue line and that red line. Let's start with the red line. What's the equation of the red line?
Y equals mx.
Well, now we actually, for the red one, we could use slope-intercept form. It's fine. In fact, let's do that. For the red line, let's find the equation by using slope-intercept form. Slope-intercept form is what? Y equals
mx plus b.
mx plus b. So for this line, what's my y-intercept? Nancy, what's my y-intercept of that red line? 1. Good. So we know b is 1. What's my slope? Jenny, what's my slope? 0, because it's a flat line, right? And we know that because if I take 2 points on this line and I calculate a slope triangle, slope is rise over run. The rise is 0 and the run is a number, right? 0 divided by anything is 0. So if I plug that information in then, if I plug in 0 for m and 1 for b, what do I get? Well, I get y equals 0 times x plus 1. What's 0 times x? 0, right? So I get the answer, y equals 1 is my equation. Where did the x go? It went away somewhere, right? Now, really focus on this, because this is where math just gets fascinating. It's amazing how self-consistent it is. So everybody focus up here, I'll see our eyes up here. So why do we not need an x there? The math gods are wise. The math gods didn't put an x in that equation because they don't need it. There is no relationship between x and y there. If there were a relationship between x and y, we'd have to have both x's and y's in that equation. Okay? Now, I'll prove it to you. Think about this horizontal line here. Tell me what the y-coordinate is when x is equal to -2. What's the y-coordinate? That would be the point right there. 1. What's the y-coordinate when x equals 5?
1.
What's the y-coordinate when x equals -1 billion? Okay, it doesn't matter, right? There doesn't need to be a connection. What's the y-coordinate always going to be regardless of x? 1, right? So y equals 1 is enough. Yes, sir.
So, like you said, it's correcting is like
Self-consistent.
self-consistent. That's crazy. That's what I mean when you brought the question, is math discovered or was it created?
It goes back to that, doesn't it? It's just like math is just this strange, thing that just exists, and it's amazing how it works as well as it does. And why is it also self-consistent, right? It just works out that way. So we don't need an x here. Y equals 1 is enough to define that line because x could be anything, but y is always equal to 1, right? Now, an easy way to remember that, if you really want to just have kind of a mnemonic device, that just means a way to remember stuff, you could ask yourself for the x and y intercepts, which axis does it cut through? A horizontal line, x or y? Y, right? It cuts through the vertical y-axis. Where does it cut it? At 1. That's the name of the line. Y equals 1. Okay. What do you think the name of the line over here is gonna be? That's the equation here. Exactly, and why don't we need a y?
It's not needed.
There's no connection, we don't need one, right? Y could be anything, but x has to be -3 at every place on the line, right? Okay? So now, moving on, parallel and perpendicular. What can you tell me, you guys probably remember this, slopes of parallel lines have to be what? Well, have to be what? Kyle, you remember, if two lines are parallel, what can you tell me about their slopes? Gotta be the same, right, so slopes of parallel lines are equal. Here's a trickier one. Tyler, see if you remember this. Slopes of perpendicular lines. That's a much trickier one, so they meet at right angles. What do you think has to be true? Now, we can kind of reason through this. If one line's going this way, if it's got a positive slope, and what could you tell me about the sign of the one that's perpendicular to that? It's gonna have to, if this goes uphill, then the perpendicular one's gonna go downhill and vice versa, right? So they're gonna be opposite signs, but there's one other tricky part of this. Negative reciprocals. There we go. They're gonna be opposite, I'll say opposite. Reciprocals. So what do we do when we want to find the slope? If I have a slope of a line and I want to find the slope of the perpendicular line, I change the sign and I flip the fraction, and that's it, right? Okay, so then the last thing we're going to do here, I think this is the last thing. Oh no, sorry, we got intercepts too. I don't forget, hopefully we get to it. We want to be able to look at two lines and determine if those lines are parallel or perpendicular, okay? Or neither. And we know what the criteria are. If they're parallel, what has to be true? Gabe, what has to be true? If they're parallel, what has to be true about two lines? Same slope, right? The slopes are equal. Do we care about anything else? No. That's all we care about are the slopes. We don't care about the y-intercepts or any of that stuff. We just want to know, are the slopes the same? If they're perpendicular, are the slopes opposite reciprocals, right? We don't care about anything else. And if neither one of those things are true, then we know that they're neither parallel nor perpendicular. They meet at some other weird angle, right? So all we got to do then is we've got to find, just as quickly and efficiently as possible, we want to find the slope of the red line and the slope of the blue line, right? How do we do that? Well, we already did some stuff like that. We did that yesterday, right? Yesterday we did some things like this, where we were trying to, for example, if I want to graph this line, what did I do? Well, I put the line into slope-intercept form, which means I isolated y, right? Why did I do that? Because once I get it into slope-intercept form, it's easy to tell what the slope is. What is it? What's the slope of this line? -4. Okay. Give me everybody see that? Raise your hand if that's, you go, oh yeah, I see that. Okay, good. So really all we got to do is isolate y and see what number is being multiplied by x, and that's the slope, isn't it? If I were doing a problem like that, did I even really have to do that other part? Not really. I mean, I don't really care what b is. If I'm just trying to find the slope, all I have to do is when I isolate y, find out what's being multiplied by x, right? So let's take that strategy and let's apply it here to the red line. So what are the steps to get y by itself there? I've got -8x plus 8y equals 0. Garrett, what are the two steps to get that y by itself? Got to add 8x first, right? I got to push everything except the y term to the other side. So we'll add 8x to both sides. And then we're going to end up with 8y equals 8x. And then last step, Marcus? Divide by 8, right? And so if we divide by 8, what do we get? So those cancel, and I just get y equals 8 over 8 is 1, right? So you tell me from that, not that we care about the y-intercept so much, but what's the slope? What's the red slope? 1 over 1, right? Everybody agrees it's 1, or if we want to think of it as a rise over run, it's 1 over 1. Because the coefficient of x is 1, right? So m equals 1, thanks to that coefficient. Here's a little trickier one. John, what's the y-intercept? It's not that tricky, but I'm 0. And good, how'd you get it? It's right there, it doesn't show up, right? So think about this now, and this is kind of an important point. If a number is a coefficient and it doesn't show up, if it's being multiplied and it doesn't show up, it's an invisible one. We just get lazy and don't write it. If it's something that's being added and it doesn't show up, it's gotta be zero, doesn't it, right? When are we out of here? 1 minute?
Yeah.
Oh my goodness, this don't have enough time.
Oh. I got a question for you, Mr. Reyes.
So I'll tell you what, we'll finish this up on Friday, how's that? Okay. Yes,
This one's about to blow your mind.
okay.